Hi, boys and girls. I'm out here at my cactus in the backyard, and today we're going to talk about exponents. Now, if you remember in the introduction of today's lesson, we mentioned that there's three forms of exponents. So I just want to see what we've got here for exponents. When we talk about exponents, we're usually talking, well, actually, we're always talking about a base, which is a particular number, raised to a power, or an exponent. In this case, we have 5 to the power of 2, which we usually just say 5 squared. And as we know, 5 squared is 25. And this form here, where you have the base raised to an exponent, is actually called exponential form because it does have the exponent. Whereas 25, the answer, is standard form. Juan is talking to Jose, and Jose says, "How do you know she loves you?" He says, "Well, she kissed me 5 squared times." No, you don't say 5 squared times. She kissed me 25 times. So 25 is the standard form of a number, which typically is your answer when we're talking about exponents. Now, there's an intermediate form also, which is called the expanded form. 5 squared means 5 times 5. So we call that the expanded form, just like 5 cubed would be 5 times 5 times 5, etc. Now, I want to talk to you a little bit about a problem I've been seeing in 7th grade. And this kind of surprises and shocks me, but I want to eliminate this problem this year. Note, 7 squared is not the same as 7 times 2. We all know that 7 times 2 is 14, but 7 squared is not 7 times 2, it's 7 times 7, which would be 49. So, boys and girls, let's make sure we don't make that error this year. Now, I told you I was here at my prickly pear cactus. In Spanish, this is called a nopal. And you can see, let me zoom in here, you can see it actually makes little fruits. And these little fruits, I'm going to put my thumb next to this one. You can see this one's pretty small. These 3 are pretty small, but they get much larger. In fact, there's a bunch of fruits up here, some of which are almost as big as a baseball. And I noticed that one of them fell on the ground last night, and I'm going to make sure I use these tongs every time I pick up a prickly pear cactus fruit. And by the way, this is kind of funny, you might enjoy this. In Spanish, the name for these fruits is tuna. Yeah, they're called tuna. It's not like a fish. I don't think these things can swim. But you got to be real careful handling these things. If I get in really close on some of these small ones, you can see down at the bottom they have some little spiky things, some little thorns, and those thorns can really do your hands in. That's why like I say, I was using the tongs when I held that up. Okay, now this particular tree, when we first moved in, it was not giving many fruit at all. In fact, if I remember right, the first year we only had a couple little tunas, little fruits, but I took good care of it, and little by little it got better and better. In fact, here's kind of what happened. And this is going to introduce a concept of exponential patterns. Like I say, the first year I only had a couple of fruits, but every year thereafter it seemed like it doubled. It got better and better. So this is an exponential pattern I want you to take a look at and learn from here. If you have 2 to the 0 power, that equals 1. In fact, anything to the 0 power equals 1. But 2 to the first is just 2. 2 squared is 2 times 2, which is 4. 2 cubed would be 2 times 2 times 2, or 8. Here again, the base is 2, the exponent is 3. Again, 2 to the 4th, 2 times 2 times 2 times 2 is 16. And you can see the pattern. 2 to the 5th is 32, 2 to the 6th is 64, and so on, and so on, and so on. This is called a geometric progression because in each iteration or each step of the procedure, you're multiplying by the base one more time. So in each case, we're just multiplying by 2. 2 times 2 would be 4. 4 times 2 is 8. 8 times 2 is 16. And then 32 and 64 and so on ad infinitum. So anyway, I wanted to point that pattern out to you because it just seems, and I'm not sure because I haven't counted every year, but it sure seems that the number of fruit on this tree is growing in an exponential or geometric pattern here. Okay, anyway, in continuation, I want you, as we end this video, to try these. I want you to get out a piece of paper and see if you can calculate 3 to the 0 power, 3 to the first, 3 squared, 3 cubed, 3 to the 4th power, and 3 to the 5th power. And, see if you can come up with those answers, and we'll throw it right back to you. This is Mr. Flathers saying, see you back in the classroom.